Perfect. So, what do I want to say? We have two cases, right? One is experimental setup and the other one is a theoretical solution. Um, do we want to make the experimental setup, or do we want to make the theoretical solution? My previous projects were theoretical. I promised to work more experimental. So let's put experimental as a priority. However, we don't have data, so we are not truly experimental. I want to develop an algorithm that we are looking at the data and how can we find these parameters, eyeballing cost and articulation cost, and for the other model it can be click probability. Well, this is actually, we have it here, probably arcsort. So we better talk about them. On this one, we better talk about, on this one we know the optimal solution, yeah. What we want to talk about is if the assumptions are correct, and if this is the model, how can we find this theta v's, and what else is left? Probability of relevance equal 1 given v. Well, this one we already know, we assume we know it from our previous studies on a homogeneous list. So let's focus on this one because I'm more interested, I'm more curious about this one. We have a platform utility here, and first they search, then they choose an item, and they cannot go very low because the eyeballing cost all right, let's go. Okay, I have two questions about this model that I'm curious about now that we don't have the meetings yet. Okay, one thing is that eyeballing cost and articulation cost, I wrote it down here. Eyeballing cost and articulation cost are random variables. We want to find their distribution through looking at data. All right, that's one thing. And we know UDV, for example, it is PD, price times expected rating minus the variance of it, something like that, standard deviation. So we have UDV. Then we want to compute eyeballing cost, and we want to, well, we have pi too, right? If we have the data set, we know that what is the pi for everything. And well, these are also conversations we can have. Here we are assuming that for the theoretical setup, we are assuming that the platform wants to choose pi. Too interesting. Okay, let's make my decision, and the rest for another day. For tonight we are gonna party. Tonight we are gonna, oh shit, give me a second. I did not upload the, shit. Sore hamstrings. I know, you are thirsty for my new, fuck that. You're thirsty for my new Armchair Theorist video, so I'm giving to you guys. File, remux it. Oh. Three fucking hours. What is it? The name? It should be clean up, even if you're messy. And okay, so this one will get uploaded in the background and we can get back to our game. We can get back to our game. And this is it. So tonight we are gonna party, and what is the party? So this is the party. I have two cases I want to study. So we assume U of dv. We assume what else? Eyeballing cost of pi of q and d. We assume AQ. Two rankings that I'm curious about are one, pi QD, right? What is pi QD? We have a, so this is Q, and this is V1, for example, V2. Okay, how to sort this one? How to sort this? One is this. A. B is okay, I have Q, V1, v2. What if I set you tell me, guys. Okay, I want to set my ranking as this. I don't know, I name it K, the first K from group V1 and the second K from group V2, right? And see, I wanna connect it to our previous model that we have Q, we have V1, we have V2, and we have arcsort theta V times. Well, we don't have probability of relevance, right? Where is it? We don't have probability of relevance. What should I put it? Instead, examination. I will say arcsort theta v u of d and v. Let's do that. Okay, these three things that we have this. Right. This is one question. This is the theoretical study. Theoretical. Which we can even code to find out the solution. I like to code. Then I wanna say something else for the experimental setup. Okay. Experimental setup. We want to say how to find out the parameters given a data set. Parameters, by parameters we mean like eyeballing cost of pi qd. I want to know articulation cost, u of d and v, and what is it? The other one is eyeballing cost, articulation cost, u of d and v, and the other one is probability of relevance equal 1 given v and d, also theta v. That's for the experimental set. So let's just start from the first one. We have this one, A. This is called D. One node, and it can relate to two nodes. How to start this part? Okay. let's see how we can go. Very simple case. We have one node Q, one node V1, one node V2, and user. We have utility of the user, we have the utility of the buyers. The platform is U of DNB. So we want to have maximizing on Q1, maximizing, that's user, maximizing on D of U of DNB minus eyeballing cost of pi QD minus AQ. That's it. And now platform should maximize expected of U of DNB. These are assumptions. I don't want to doubt on my assumptions right now because there is no point in it unless we have a conversation with other people. So maximum theta this, and also another one is that this term, right? Should be non-negative. And one other thing we want to say is that what is this platform? The platform is and if D is empty, then platform gets 0, right? It is theta Vi. Okay, simpler than that. We have only two nodes. Theta V1, U of D and V1, D1 and V1 plus theta V2, which is 1 minus theta V1. Actually, I can call them theta 1, theta 2. Theta 1, theta 2, U, D, and V2. Alright. So, assume if V equals V1, if consumer is of type 1, what happens, right? If consumer is of type 1, then and type 1 and Q, he chooses Q as V1. Then D will be argmax U of dV1 minus eyeballing cost pi of Q, which is V1, and D, and users net utility will be U dV1 V1 minus eyeballing cost of pi V1 and D1 minus A of Q of V1. That's it. If user's type is V1 and Q, he says Q1 instead of being completely articulate. Alright, then D1 DQ, what the fuck should I call it? Yeah, DQ1 will be argmax U of D and V1 minus eyeballing cost of pi Q1 and D minus A. That's it. And then user's utility will be Jesus. And this should be non-negative, by the way. Okay, that's why I like to do coding, because these are all just theoretical and I don't know which one is which one. However, we can say some stuff without code too. User's net utility will be U of dQ1 and V1 minus eyeballing cost of pi Q1 dQ1 minus AQ1. This term should be non-negative as well. So one thing I want to say is that if V1 is a more specific version of Q1, we should have the orders of items that belong to category 1 when they are searched for a more general query should not change, right? If you are for type V1, if for this node here you have a list, well, yes, you mix it with this is list 1, this is list 2, well, you mix it for list 1 and 2, but the order of the items in list 1 and 2 won't change, right? Why should we change it? If D and D prime in, for example, V1 or A and dV1, right? And U of D and V1 minus eyeballing cost of pi. If you have a good ranking, eyeballing cost of V1 and D. This is better than U of D prime, V1 minus eyeballing cost of pi V2 and D, V1 and D prime and assume they're all positive. Which one platform the ones at the top? Well, D is the one that is being sold. D is the one that will be sold. But platform is actually looking for the one that has higher U. So if I am the platform, I will put the higher U at the top. Okay, this way utility of the user and platform are in the same direction, right? I'm the platform, I am putting the higher U, D, higher, so U of D and V1 greater than U of, this is a good platform. This is a, I want to say, kind and good platform, right? That his utility is actually utility of the user. So D prime and V1. I rather sort pi V1 and D less than pi V1 and D prime. I want to put the D higher so that I make sure that item D is sold. However, we know that I have some room to replace them. Actually, it's good to know that, to add it. I have some room as the platform. Maybe, perhaps, to change the order. If the cost of, for example, eyeballing cost is not huge, the changing cost of eyeballing is not huge compared to the utilities, you may switch them. Still, item D will be sold. Item D prime will be at the top, but item D will be sold. And platform gains the same utility. User does not gain the same utility. So that was a good comparison. Even here, platform, for example, maybe platform gets some, if we assume platform gets some money from the sellers that put item D prime higher. But platform knows that the item D still will be sold. User will buy if it is not negative, if eyeballing cost of the change does not make the user buy the item D prime. He's getting his share of the sale, and he's still getting UDV. User gets a bit more eyeballing cost. I mean, even this is beautiful, very eye-opening. Perfect, that's a good model. However, if I am doing this, then if it's a good, meaningful change is that when Even when it comes to general, probably you don't wanna. Based on my Boolean cost, you may wanna change the. Maybe you don't have a room. You don't have room to switch their position now, but you have room when they are searching for a more general query. It is possible. So one thing for sure we have is that pi qd is always greater than pi vd for any item. For each d in a dv and v in q. That is for sure. But the only thing I want to know, if for example pi of d and v greater than pi of sorry, less than pi of d prime and v, will we change? Can we say that oh, it is v and d, all right. Can we say that it should be like that? It makes sense. It's a congruent ranking. Let's name it congruent ranking. Definition: congruent ranking. I mean, if you are not bringing any incentive from the seller side, why not do that, right? Pi of q and d. For a more general query, still we keep the item d above item d prime. So if sponsored listing comes into picture, maybe for a general query we have room to switch. That's one thing. And then we want to say so let's assume we have assumption. Congruent ranking. I mean, it's not an assumption. For any ranking pi, we can come up with another ranking that comes with the same utility for the platform and is better for the user, which is more congruent. Actually, no. So I want to say for any pi, we can come up with pi tilde, which is congruent and leads to same utility for platform. How can we say that? Let's assume two items are switched when we are looking for a more general query. If we change their order back to where they belong, well, we are assuming that the user has a type, so they're still looking for the same items. The eyeballing cost increases, and give me a second. Well, only for the first, for the intents, we are sorted completely right. If this assumption is here, kind, good platform, here is right, then we can say it. If the platform doesn't know UDNB correctly, then we cannot say much. Because why I'm saying this? Because first of all, AQ changes. We have more room to bring it lower for sure. Does this change the decision of the user? We still want to sort based on U of DNB. Yes, I mean, if you're a kind platform, we still sort based on U of DNB. Because you care about your U, which is U of the user. Exactly, that's true. And so we're assuming congruency. And then, what do I want to say? And then we want to say, so we don't have the pi, we want to kind of actually find the optimal pi right away, which is what if it is V2, right? If it is V2, the same thing. if V is V2 and Q is V2, we will have user's utility as UD2 UD2 V2 minus eyeballing cost of pi V2 D2 minus AV2, and if V equals V2, Q is VQ1, then user's utility will be so he will choose the same object. That's it. If we have a congruent list, we know that user's choice doesn't change as long as we are staying positive. So for a congruent list, user's choice does not change as long as we are positive. As long as IR is satisfied. So let's assume IR is gone for now. Maybe if IR is not, because we are decreasing articulation cost, we are increasing eyeballing cost. So it depends where they cancel each other out. So assuming that IR, we are not observing IR, we will have U of D2 and V2 again, the same object will be chosen, and minus eyeballing cost of pi Q1 D2 minus AQ1, right? Therefore, user's cost change delta user Q user utility from Q to V1, user's net utility from Q minus user utility when they choose V1 equals Q1, sorry, when they choose Q1, and then item is always D1, right? D1 1 and D1 is tell me. Okay, Q1 minus D1. So you have an improvement. The utilities are equal, right? U of Q, U of V and D are equal, cancel each other out. You have improvement on articulation cost, which is A V1, which is more costly, minus AQ, plus you have improvement in eyeballing cost, which is eyeballing cost of pi V1, Q1 and D minus eyeballing cost of pi v1 and d, right? Um, so it depends how this articulation cost matters, right? If you are just adding one length, one sentence, right? Not character, one word. So this articulation cost is like +1 if we assume it is linear, or I don't know, 1a, and this eyeballing cost can be is like pi q1 d minus pi v1 d, right? uh, Articulation cost increases, sorry, we have better articulation cost, which is positive. We have yeah, that is negative. Eyeballing cost increases, right? Minus this plus this. So we have this minus this motherfucker, which is positive, and depending on how big A is, you have more room to like the funny thing is here is that if you are sorting and we know the order of the things, then user only cares about the first two elements on the list. Which can to lead to flea market when the list, the number of categories increases, right? And which can lead to more categories when the list increases, exactly. This is on this big assumption that we know you. Huge assumption. Big assumption is that the platform knows you of DNB. Well, even if we look at Negin's paper, they were saying that it's just a random variable to both platform and the user. You know? They were random variables in Negin's paper. So there are numbers. If it was numbers, it would be easier, right? Now the funny thing is that it is random, right? If we assume these numbers are random, now we are kind of mixing the randomness from the utility of the item and also another randomness from the categories. Well, okay, above ranking, if any question, if we know the use, it is stupid to, any question will be done. Because ranking is all about we don't know the use. If we know the U of DMV, on the first, on each specific intent or query, we just sort them based on their U of DMV. The first item will be always chosen. That just determinism here hurts the model, makes it just very obvious. And we know that platforms do not know, users do not know which item is the best. So U is random. Actually, Nagin's paper was assuming that these random variables are just very random. You can ask, is it the same amount of randomness for both platform and the user? I don't agree. Probably platform has more knowledge about U of DNV for a typical user. And if they are random variables, that would be too complicated. Right? What about B? What was B? Well, that's stupid. I want to say, if this is the case, flea market is the answer. which we know it's not good. This one also is still in flea market. Interesting. And then one thing that, okay, also one thing that is missing from all of these models that leads to flea market is comparison of items within the same group. We don't model how it matters to consumers to compare the results from the same category. One reason all these models lead to flea market can lead is that we do not model the effect of comparison among items of same category in decision making of the user. And it goes back each listing reveals a signal about the U of DNV. That's it. I feel listings, it is kind of Negin's paper too, right? Maybe it's exactly here. This thing, she was like common utilitarian idiosyncratic part, and the common part was the signal that you could see. They assume that it is the sum of the two parts, and one part you will see once you look at it, and the other part is like when you go to the consideration set. Info. So you can increase the expected utility once you are maximizing the utility. And if two items are from the same category, that comparison is also informative. What was the second part? Well, okay, a lot of things opened up, even though it was super simple. Oh, actually, I think second part is not that important anymore, unless we add like, what is this one? This is stupid actually. We want one from category 1, one from category 2 that maximizes the rest, set them. As long as we know U of VND, ranking is bullshit. You just set the first two or first one in each element and you are good to go. What is C? The same bullshit. Now I think it makes sense to go how to find these elements, these parameters. Now we want to assume they're random variables. Let's find them. Interesting. Oh, it is working. Shit. Oh, but it's not writing. Okay. That's it. That's so u of dnv should be simple. Sorry, random. So u of dnv should be random. You cannot, as a user, know. Okay, this is u of dnv. Or even the platform, assuming that this is common knowledge, is bullshit. And there is no point in it. Even we don't need to code, everything is simple. There is no need to simulate. So okay, let's come up with a RAM model that is random. Mission. Our mission is for theoretical come up with a random or probabilistic model for u of dnv. That's it. And I love to play counter, but it's not the time. I want also one more thing. Experimental setup. Okay, let's go over the experimental setup. Now that we talked theoretical a bit. Experimental. Experimental, if I want to say experimental, what should I say? So we have a user that chooses, for example, max q max udv minus d, for example. Kind of here it should be kind of expected now, because we know that u is kind of expected. Minus eyeballing pass. For now, we don't even want to find the best pi. We just want to say what happens for a given pi. Right? Something like that. And so for when they search query v, what are the odds? What are they saying? We have, and they choose an item. means that u of v minus eyeballing of stuff pi for each q. When item, this is a random variable rv, and this is an rv, rv, u of d and v minus eyeballing pi q and d, exactly, that is also the problem with the clique model. Clique model also doesn't say anything. Not say anything about comparison. They just say item is relevant. You just need to be seen and you need to be observed. If it is the case, then I want to use the clique model. And I want to say, okay, equivalent of r equal 1 is just u of d and v greater than or equal eta. There is some threshold eta that u of d and v was greater than eta. And eyeballing cost was greater than 0. That's the bullshit part. Okay, u of d and v greater than eta and minus aq. These are just random variables. Greater than or equal 0. This is what we learned from the observation. Is it what we learned from the observation? What we can say from a query clique, if that's it, observation. I think that's what we really want to focus. What a clique tells us. How we from the data set. This is the main part. How to interpret a clique. If it is a maximization, well, this model is far simpler than a maximization. How to interpret the clique is everything. For an experimental setup study. right? In position bias model, very simple. Also, it works is that, okay, item is relevant and it is observed. That is it, and Eclipse tells that to us. Here we can say, okay, item is good enough, greater than eta, and the cost of eyeballing and articulation is not that big. Similar, it ends up in a similar, I probably think. And then what are these random variables? Each click tells us about these random variables. And now we want to find the distribution of them. Is it it? Or if it is more complicated, maximization. It is telling us that u of d and v minus eyeballing cost of pi q and d, for example, is greater than or equal u of d prime and v minus eyeballing cost of pi of q and d prime for each d prime in dv, right? If d is chosen, that's what we get. Also, it sounds more complicated. Also, we can say pi is fixed, right? Well, it depends on our data set, what we have. And then we have, for each q also, u of d and v minus eyeballing cost of pi q d for each q prime minus aq, for example, greater than u of d and v minus eyeballing cost for a congruent listing, for a congruent pi. Eyeballing cost of pi of q prime and d minus aq prime. And we have bunch of random variables and bunch of inequalities, and find them. What are these random variables? What are their distribution or whatever? And like it is greater than equal 0 as well. Equal 0 as well. So what do you do if you have like bunch of random variables x and y and z, and like x greater than y? and each click is one user I. So for example, user I says xi greater than yi. User j says xj greater than, less than or equal yj. What can we say about x and y? Right? Simple. Simplest case. And user 1 for I, x and y are RVs. I, we have n plus m realization of them, and I 1 to m n xi is greater than yi, I n plus 1 to m xi is less than yi. Okay. It's not very complicated, right? And these experiments are independent. Right? What we say is that, let's assume the experiments are independent. What we want to say is that, okay, what was it for university? Let's assume like EM. Let's go EM again. Assume one, find the best for the other one, EM. Assume we know PY, right? What happens is that it's one of kind of maximum likelihood thing. We know that xi is greater than yi, which is a number. Probability of, what is the probability of xi greater than yi is py. These are numbers, these are realization numbers. This will be py of xi, right? And probability of xi less than yi equals py of 1 minus py of xi, right? And we want to choose pi I plus m, sorry, n p y of x I n plus 1 m. Now you can say, okay, we know y. What is the best distribution for x? Because these x's are numbers, these are not exactly. So if py is in a family of like that is parameterized by theta, assume we know actually px. So like argmax on theta that does this for us, and then we will find a py, and then also assume px depends on family that changes by not theta but fucking gamma, and py is set. Now we have this set of probabilities also, which is 1 minus, for example, 1 minus px of yi, yes, yi, and this one is px of yi, for example, and this will end up so this one gives us theta, and then we have py, then we want to argmax for theta star on gamma 1 to n something like that, and this will lead to a gamma for us, gamma star. Well, okay, it is just 2 steps, it's not like 10,000 steps repeatedly. Once you have theta star and once you have x gamma star, that's it. Or you can also say like probability of x greater than y, what is it? It's like x greater than y. And like if they are independent, it is like independence, it will be it's actually fyy dy x squared 1 minus something like that. Let me ask ChatGPT. If there is no parameter, how can we do that? Clean up even if you are missing. Okay. And we have n plus n observation for random variables x and y for I one and x of I greater than or equal. What can we say about x and y order distribution? If Well, that's very easy problem, yeah. I mean, maybe this optimization is difficult, but that's how you should do it. Yeah, right. That sounds very nice, actually. Yeah, I think I need to have a talk. Also, I guess I wanna go check the experimental setup in the last two papers we read. In Negin, now that we talked about it, now we can. One is Negin, the other one is position bias. And I want to do position bias first. And I want to talk with Epsilon first, actually. Okay, good. Now let's go play counter. Because we deserve it. So, for warm-up set, I want to just do left and right. And left and right, yes. I think that one of the biggest differences that we want to study is that the effect of information, like effect of comparison, dude, all of you. Effect of comparison, BNB. Compare. When we compare, when we are in a list. Effect of comparison when we compare. Bro. Brotherfucker. Jesus. Maybe I lost. I saved you, man. Jeez. Alright, bitch. That was a good game. This is the warm up, by the way. It's working, left and right. Oh, bro, fuck off. Plants, who's plants? Ooh, so fast, bro. His fucking button. No. Who has a gun? Wow. And he was. Oh shit, okay. I didn't choose to buy. Okay. That was crazy. He was so fucking fast. Well, I was practicing left and right. Dude, come on. Bruh. Oh, that was harsh. Alright, they're all clean. What the fuck? Jesus. Bro, okay, this is just killing them, man. Where are they? There's one here. There's one here. No, good. Jesus. That was a shit show, bro. What the fuck is that? Jesus. Where you go? Jeez. Right, tectonic is good actually. Whoa, watch out. Ah, fuck. I got stuck. Wow. Jesus. Alright. They're not the same. Okay. Bro, jeez. They got better. I got better too. Oh, okay, that's the best thing. Go package. The plane train, most damage. Most kill Zeus, God of Lightning. Clickbait. What is the clickbait? What does clickbait mean in Counter-Strike?
In Counter-Strike, clickbait typically refers to misleading or sensational content, often in the form of video titles or thumbnails, designed to attract views by promising something exciting or sensational, which the content doesn't deliver.
No.
For example, a video...
Fuck off.
Ah, got it.
A player is labeled as the name I said you.
Oh, gotcha. In Counter-Strike, a player labeled as clickbait might be someone who draws attention in-game, perhaps by frequently baiting other players into... Oh, I see what you mean. In Counter-Strike...
Actually, this version of ChatGPT is funny. Oh, oh, I know what you're saying. Oh, I know this motherfucker. Oh, okay. Jesus. Bro, come on. Okay, This is done. He headshot me. Bro. Three of them. Bro, come on. I'm scared. Where are you? Oof, bro. I'm killing good. Jesus. Ah, don't. Ah. Bro, fuck. Who is shooting? Motherfucker. Don't. Third time, maybe at least. Bro, fucking bot killed me. bot is coming to our isle. That's unacceptable. This motherfucker jumps all the time. This ones have more accuracy. That's it. Jesus. Didn't kill. Is this a joke? Don't shoot that, okay. Dude, even if I am holding, you cannot tell me I'm not killing you. Just wants me to. Oh shit, dude, what's up, man? Wow, two bots are better than me.